I wanted to take a moment to go over the wiring that I've done on Johnny 5. This is the wiring that I have gone with. This is not necessarily the wiring that may be documented later officially, but this is what I decided to do for my own build. I just wanted to take some time to go over it with you. So basically, starting off with, as you guys have seen before, there is batteries and wiring in the tracks, of which come out to this area right here. And you've got the main 24 or 12 out of each track, 12 volts coming out. This is one of the main connectors. This is the BMS connector. So when you're doing the charging, you pull this guy off, connect this up to the BMS, connect this up to the BMS, or in my case, the iCharger, and do the charging on that. I've also got a data line running out of here. So for my build, I have motor controllers in the tracks themselves. Some people have elected to do the motor controller in the cradle base, which is totally fine. But I had already mounted them in the each track, so I stayed with that design, and I ran the data line coming out of here as well. One thing I will mention for those that are building, this collar right here that we had manufactured, mine, for whatever reason, on my left track would not fit the tube, this tube here. For some reason, it was extremely tight. I could not, when it was on the track itself, I could not lift the track up and put it on the cradle base. It was just too tight. So I ended up having to completely disassemble this, take that collar off, and sand the inner diameter of it down, and then did a test fit. It still was snug, but not overly tight. Put it back on the track, and then I was able to put the track on. So whatever reason, it was just slightly out of spec. Not uncommon in this build. Everything's very tight tolerances. So if you haven't done that yet, I would highly recommend checking those collars against the tip-toe tube, or the tube here, way before you put it together. So back to the wiring. I basically ran from here and through the plastic or the ABS printed wire tunnel, and then inside the tube here I actually have Anderson connectors, but basically I elected to do the Anderson plugs because if I needed to go to take this track off, I don't need to completely disassemble the cradle base area in order to get the wiring out and get the track off if I need to take that off individually. It does crowd the tube quite a bit, but it worked just fine. Another thing I've elected to do is go with, I believe this is 10 gauge wiring. There's two lines for each positive and negative. I did that over using the flat wire that is specified in the CAD. That's just my personal preference. I just elected to do it this way. No particular reason other than that flat cable was a little expensive, and I just decided to go with something a little different. Once the wires come in here, basically I've got a set of wires that are back up in here, connects the positive of one track to the negative of the other track, and they're connected to an Anderson plug, so I can disconnect those and separate them if I needed to for troubleshooting. And that brings it to the 24 volts, of which this line now is positive for 24, and the negative for 24 actually goes into this plate. So let's talk about this plate. This plate is not in the CAD either. I decided or came up with the idea of elevating my electronics and not actually putting them into the bottom plate of the cradle base for two reasons. One, I didn't want to drill holes in that bottom plate. I didn't want to take a chance of drilling the holes in there and then later on changing the design or changing the electronics and then having basically that plate Swiss cheesed and having holes in it that weren't being used. That plate is extremely difficult to bend, and I don't want to have to replace it. So that was one reason. The other reason was just basically for neatness and routing of wires and preventing the crowding. So you can see back here, I've got a number of wires that are going straight under this printed piece. This is PTEG, and so I printed that on my printer. Now, could I have gone with like a metal plate? Probably. But honestly, I like having the non-metal plate simply because it's not conductive. So if something was to go astray here, it's not going to short out against the metal. I basically designed it to where it's utilizing the existing screws that already come up out of the bottom. and I just put longer screws in. Now these are not completely extended. They are still somewhat, there's probably another quarter of an inch that can be used, and that'll pop up against above that plastic, and then I can put a nut on it. I just haven't done it because I'm not final on this wiring. It's mostly done, but until I get the upper half of the robot done, I don't want to lock this down and then have to be unscrewing it. So I've just left it like that for the moment. So I think that overall it looks a lot neater with this design. Obviously other people have done it different ways, and that's totally fine. Once the power comes in here, I've got it going through a 60 amp fuse right now. I don't foresee needing anything beyond 60. Obviously I will adjust that as time goes on, but so far the current capacity of this robot and even the spikes that occur upon startup have not gotten close to 60 amps, which is why after I go after the fuse, I'm going to an 8-gauge wire, and then that wire comes up to what I really think has turned out very well. Is back here in the rear of the robot, I've got several things going on here. This is an off-the-shelf board. This is not a custom board, it's from Amazon, and it's just a power distribution board. And what I've done is the 8-gauge comes up, it actually comes up through this, I think it's a marine switch, but basically it's an on and off switch. It just, there's on, there's off. So this is my master power. Right after that fuse, I've got this master power. If anything happens, I can shut it down right there. I cut out a piece of aluminum plate here to the shape of this, and then I riveted it in, and then I cut a hole in it, and I put the switch. So I felt like there's some extra real estate here that, you know, could be used. So I went ahead and used that. The cover that goes on here, there's a standoff that goes here. It completely clears the switch. The switch is not impeding the look or how that cover goes on there. So that actually worked out real well. Now it gets really close down here to the bottom plate. So what I did is I took some material that actually was getting with one of my 3D printed reels, filament reels. So it's a non-conductive sticky material, and I was using this filament called, I think it was Cool Bean, I guess. It's what it says on here. So this is it in its complete form. I think it's supposed to go on your 3D printer bed. Mine is so much bigger, this doesn't help me. But so and it's sticky and it's non-conductive. So I basically cut some of that up and I stuck a piece in there. Also took that same material and I put it on the bottom of this plate that basically goes right here. So if I zoom back, so this plate goes in here on top here, and as you can see, that motor, I mean, it's not super close to the lid, but it's close enough that I didn't want it to take the chance of it arcing, so I stuck a piece of that material there as well. I'll talk about that connector in a little bit that's on that lid. So getting back to this, basically this is a distribution block. So after it goes through the main switch here, it comes back down to this solid state relay. So I decided to go with solid state relay because I don't like mechanical contacts. They tend to char or oxidize over time. So there's a risk of, you know, them latching closed and so on and so forth. So I just decided to go with a solid state relay. It comes in one side, it goes out the other, and then it goes to this screw strip here where it's distributing out the power to different areas. One of those areas is going to be up to the upper half of the robot, which right now is obviously not wired up. Another is to this little guy right here, this red connector that goes to the power switch. I'll explain that in a minute. And then you have the two red lines coming off here going up to this distribution block. So those come in here. The ground, by the way, when it comes in, it goes underneath, comes up, goes to this ground distribution block down here, and then comes up here. Once it comes in here, we've got these fusible links here. Now what I've done is I've actually taken away the fuses on the ones that I'm using, and I've put these breakers, mainly because if it blows, I can reset the breaker as opposed to having to carry around a bag of fuses. So far I've stuck with 5 amps on each of these channels. I don't foresee The most that would probably be pulled on this block would be the track drive. So the track drives are on these 2 channels. These 3 channels are other things like the actuator, the mid-torso, and the tip-toe. Tip-toe might also pull some pretty good current too. I haven't actually measured that one yet, but I have ran the tracks and I have ran tip-toe since this was done, and neither of them popped. Now, for the tracks, they're pulling a little over 5 amps. Let's just call it 5.6 amps or something like that is what I've measured through my EMS. And so you split that by 2, then you're only running like a couple, 2.5 amps max on each track. So very much within the tolerance of those fuses. However, if for some reason I start to have some problems there and they start getting close to the upper end, I can always upgrade those to a 10 amp. So wires come in here. You know, we got the positive track, we got the negative, all that good stuff. Now, what happens next is the wires come out of that and they go to the individual devices. We have these ASMB03 controllers here, and I've labeled each one to what they go to. And then, so the first one is the tip-toe, the second one is the lower actuator, and the third one's the mid-torso motor. Oh, one thing I forgot to mention is this solid state relay obviously has a negative and a positive input on it here. So this is how it's turned on and off. So up here I have a push button that actually engages this relay once the main switch has been turned on. Now, another thing that I'm going to do on my build is, if you notice here, I have a little relay on a board that's kind of sitting down there. It's not connected up yet on the one side. But what it is it's a board that's an interrupt. So this is an interrupt for the low voltage side of this relay. So what this will do is this relay it'll allow me to remote kill the robot in the event that something is going wrong and I'm not able to get to this power switch quick enough. How I will be able to do that is I'll be looking at having the remote itself or the receiver power up or be able to power up outside of pushing that button. And it will come on when the main switch is thrown, but all the other electronics won't come on until that button is pushed. And the main benefit there is that A, you make sure your remote is fully connected and is enabled prior to powering up all the individual electronics, because what you don't want to do is have your remote syncing to your receiver while everything else is also powered on, because then you tend to get a runaway situation potentially. So by powering up the receiver and then powering up everything else, having that individualized, then that's much better. And that also will allow this relay to function outside of the normal circuitry that's tied to this button. So that's the idea. Haven't got it all wired up yet, but that's what's going to happen. Let's see what it looks like when I power it up. So I go to flip this guy on, press that switch there, got a nice little blue light on it, and then everything down here is operational. So let's cut these lights off. You can see the controllers are flashing. You can see the red LED on the relay. So if I hit the button off, I hit it on. So it's a nice little indicator there. And now I did mount this relay on the back metal plate there. 2 reasons for that. 1, I don't have any more room on this area. 2, it's got a heat sink on the bottom of it. I don't anticipate it'll ever get hot enough to be a problem, but it's always best to be able to dissipate heat. So I mounted it to the back metal plate there, this angle plate, the sheet metal like this that's on the bottom, so we could dissipate through that. So that's it. I mean, essentially that's the wiring. And you know, anybody out there might have any questions. Oh, one other thing. So I was mentioning earlier this connector here. So I had these CPC connectors. I've had these things for probably 15, 20 years already, because they're kind of expensive to buy, but I had them already. And so what I've done here is for the lower torso, I've got a connector here. I've got 2 power, 3 data for the potentiometer. This is coming out of here. And then what I'm going to do is on the back side of this, I'm going to put like basically I'm going to put a female connector that'll connect to this. That'll be about that long. It'll just barely come out of there, and that'll connect to that. And then I'll basically coming off this cable and this cable, I'll put another one that'll connect to this. Now you're probably asking, well, why are you putting a female connector there and then another female connector there, and that's four connectors? Well, here's the reason. This will go on there, and and then this basically I can't totally put it on there right now because that remote is hanging there from my test drive, but basically this will sit right up against here when this is all in place, and the cable coming out of here will go right into this along with the potentiometer cable. And what's really cool is this cover sits perfectly to where that connector just peeks right through that crack. So the cable will go right down through here, and then it'll connect right into that. And then if I need to take this off and troubleshoot with it off, when I pull this off, then I can undo that connector, and I can plug that connector directly into this. And I don't have to worry about any kind of weird wiring or disconnecting crap and putting crap on. So basically, this is just a short extension, cord, if you will, that's going through a panel. Bulkhead connector, I guess, if you will, but they don't really have a bulkhead connector, so I got to kind of make one. And then this will just be able to connect directly to that, or connect to this, which then will connect to that. So that's kind of the idea. So I think that'll work out real well. And by the way, and I also had the parts. I mean, I had everything but the female pins, which I have ordered. That's why this is not finished. So like, why not? If I have most of these parts, might as well use it. Which, by the way, is the case for a lot of things that are in this build when it comes to the wiring. Like this pink wire here, is a wire I already had. It had enough conductors. It worked out great. A lot of the power wiring I didn't have. I did have to order a lot of that. But the data wires, like these wires here, I already had. This is a bunch of PC cabling that used to have like a D9 on it and some other things that I have rolls and rolls of. So like, why not use it? It's perfectly good wire. It's got multiple conductors, so it works out great. So that's it. I hope that's helpful to some of you that are doing the build. And if you have any questions, you can always let me know. But that's kind of where I'm at with it. My next phase of this is to I need to calibrate the tip toe. I've got the tip toe connected up, but I haven't got it calibrated right because it wants to continuously run when I start it, even though it's connected to the pot and it's connected to the remote. So I've got some setting wrong somewhere. So I need to work on that. I'm gonna finish up the wiring on the lower actuator and get that going. And then really at this point, I'll probably move back away from the electronics and then get back to doing the hardware, getting the bearings for this, looking at trying to figure out getting the motor. I think it's really expensive, but try to get that and start going vertical. So I'm really happy that this stage of it is over with, because this was a lot of work. I mean, bending over and doing the wiring on this, it really takes it out of you. So I'm really stoked that this part of the build is done. So hope this was helpful to some of you, and I hope others you enjoy watching the videos, and we'll talk soon.